When last we left off, we were talking about nested if statements as a means of making complicated decisions that require more than one factors to be evaluated at once. And so here's a quick flowchart diagram of what we were looking at last time with our nested if statements, which is to say that our program flow comes in, we check to see if our number is odd. If it is, we check to see if it's a multiple of 3. If it is, we check to see if it's greater than or equal to 10. And then if it is, we check to see if it's less than or equal to 30. And then in all cases, if our number is not odd, we roll from there. And this last one, like if it is less than or equal to 30, we output a message, and then we rejoin our program here in just a little bit. So it's with nested if statements, the thing that should very quickly become apparent to you is that if we have lots of things that we're doing here, this ends up being a really complicated piece of software, and more specifically, it becomes really, really difficult to maintain and to edit. Right now, that's one of the concerns, that's one of the considerations that we should have, is making sure that we are writing software that isn't very difficult to change later. The problem with nested if statements is that after a certain point in complexity, they become a giant pain to change. They become a really big deal to mess with. The other problem that we have with if statements is that we can't guarantee that all of these things will be checked. So if it is important, for example, that we collect some input from the user and then tell them everything that's wrong with that input, instead of just the first thing that's wrong, nested if statements, while usable, generally aren't going to cut it. So I want to show you a different technique. This technique is called the Boolean flag. And all that we really do is we set up a flag variable, which we almost always represent as a Boolean, to keep track of if something is valid. This only really works when we're talking about a complex evaluation where the end result is either yes, this is good, or no, it isn't good. But I'll show you an example of that. As we're going to take the previous program, the one where we check to see if our number is an odd multiple of 3 between 10 and 30 inclusive, and we'll just re-represent this using Boolean flags. And so what basically happens here, we check to see if our number is, what basically happens here, we create a Boolean called isValid. Right? Booleans generally start with an is or a has, if we can, which is just going to be a representation of whether or not our choice is valid. So if isValid is true, we've got a good number, and if it's false, we have a bad number. And so we're going to start by assuming that our number is good, and then we'll see if we can disqualify it. So we're never going to do anything to set it to true. We're just going to start by assuming that. We are, however, if any of these conditions don't work, we're just going to set our number to false. Okay? And so what that's going to look like is just a series of if statements. These aren't nested inside each other. I omitted the curly braces for readability and for space, but we're not nesting anything inside. Right? So if our number is even, remember that we want an odd multiple of 3 between 10 and 30. If our number is even, we just say isValid is false. And then if it's even and it's not a multiple of 3, isValid is still false. If it is a multiple of 3, we just don't do anything. Maybe we output a message, but we don't do anything to change the value of this isValid, other than to make sure that it switches away from true to false, if need be. If it's less than 10, we set it false. If it's greater than 30, we set it false. So it's possible. Like let's say we have a 6, which is an even, let's say we have 8, which is an even, not multiple of 3, that's less than 10. We might set isValid to false 3 times in a row, and that's fine. That's not going to break anything. Okay, that's not going to be a problem at all. Now the benefit to this structure, the benefit to this particular structure, is notice how easy this is to modify, and notice how easy this is to write and keep track of. We don't have to worry about making sure that our curly braces match up. We only have to worry about making sure that our isValid flag gets switched. Now compare that with with this structure, where we have to make sure that all of our curly braces match up, and we have to make sure that our indentation is right, and we have to make sure that all the conditions are right. Just more stuff to keep track of. It doesn't necessarily mean that this structure is better. It just means that in a lot of cases it's easier to use. Let's put this into play real fast. Okay, so we've got a new class. It's public class Boolean flags. So we'll make a scanner, declare main method, create the scanner, or import the scanner, create the scanner, do a quick output of a title, ask the user for a number, and then we'll roll from here. So now, from here, we're going to create a Boolean flag. Notice how this turns blue. What that means is that it's a type of variable. Remember that Booleans just hold true/false values. So it'd be isValid. We're just going to set that to true. We're going to assume that our number is good until proven otherwise. This is all of our tests are going to see if the number is bad, and so from that we start to see if the number is good. Okay? And the reason for that is because all of the tests have to pass in order for the number to be good, but one of them can fail. One or more of them can fail to make the number bad, which is to say we're going to go with the thing that's more likely. We're going to go with the thing that we want, and then see if we can disprove it. So from here, so if our number mod 2 is 0, right? So if our number is even, we can say system.out.println error, number is even. Okay? And then from here, we just set isValid to false. And we're never going to do anything to set it true. Okay? Now we have our next if statement, which is if our number mod 3 is not equal to 0. Right? So if it's not a multiple of 3, system.out.println error, number is not a multiple of 3. We'll just set isValid to false. And then, if our number is less than 10, system.out.println error, number is less than 10. And we set isValid to false. And finally, if our number is greater than 30, system.out.println error. Oops, helps to have a parentheses there. Error. Number is greater than 30. Then we set isValid to false. Okay? Now the thing that we have to do here, if we want to tell the user that the number is right, now all we have to do is check to see if isValid is good, right? And so you can say, you can do something like, if isValid is true, system.out.println good job. Else, system.out.println sorry, there are one or more errors. And we close it out. And now we're solid. Okay? Now note, with this structure, there are a couple of things that are different. Thing one is that instead of worrying about a nested structure, we just got a whole bunch of things that are right in a row, where each of these evaluations is independent of the others, which means that all of them are going to happen. The second thing to note is that instead of keeping track of all of this using sort of an implicit nesting structure, we're keeping track of it with the Boolean, so we're creating this extra variable. And you might be thinking to yourself, oh gosh, I don't want to take up all that extra memory. But with regard to the primitives, and with modern computers being what they are, taking up this extra memory has almost no effect whatsoever. Right? A Boolean, for example, takes up a single byte for the data itself, and then a few more bytes for like the name and the address in memory and whatnot. But by and large, though, with these values, they take up almost no space, and so you'd have to make millions and millions of Boolean values. And I mean that quite literally, before it started to have any real effect on the memory of your computer. Probably billions, maybe trillions of them, before it started having any meaningful effect on your computer, assuming that you're running a relatively modern PC. The last thing that we should check, the last thing I want you to note, is that by starting and assuming that everything is true, what we're doing with each of these checks is to see whether or not it's bad. Okay? So we're checking, so here, we're checking to see if our number is not odd. We're checking to see if our number is not a multiple of 3. We're checking to see if it is not greater than 10. and then if it is not less than 30. Okay, now this is different from what we saw earlier. This is very different from what we saw earlier with our nested if statements, where we check to see if it is odd, then we do the next check. If it is a multiple of 3, then we do the next check. If it is less than or equal to 10, then we do the next check, and so on. And so what that means then is that we're testing different things. Okay. Now the really cool thing about Boolean flags is that they're really good for complex evaluations. They're really easy to modify, and they're a lot harder to screw up. In that you're not ever going to have to really worry about misplacing your else statement or something like that. And also with the Boolean flags, if we're using them for validation, we can use them to catch all of the errors. Remember, with the nested if statement, we only evaluated as far as our statements were true. Which means that sometimes we skip these steps. The Boolean flag method, we're checking everything. So if you want to check everything, if that is important to you, then this is a good method to use. The last, oops, don't really want to open up Microsoft Excel. Then the last thing that's really nice about Boolean flags, and we're not going to talk about this for a couple of weeks, is that they're really good for sentinel-controlled loops. And we'll talk about that in a little while. The disadvantage, if there are some, one, it takes up a little bit more vertical space on the screen. It's less horizontal space, which is to say that there's a lot less indentation and a lot fewer things that we have to worry about in terms of making sure everything fits on the screen. But it does take up a little bit more space, and that's a slight disadvantage. Every evaluation has to be checked, which can be an advantage or a disadvantage. If it isn't important that every evaluation be checked, then it's a disadvantage. If it is important, then it's an advantage. And then finally, the Boolean flags method is only really good for making sure that you have, at the end, either a yes, this works, or a no, it doesn't work, a true-false value at the end. If you're looking for something else, you're just going to need to use a different technique. And the same thing is true with the nested if statements. In general, the thing that I'm going to suggest is that instead of making complex nested if statements, you try to use the Boolean flags method. This one is a lot easier to use, and it's a lot less error prone. These are design decisions that you can make. All right, so let's save, compile, and then run this baby. Java-C Boolean flags, and then we have an unclosed string literal. All right, so we need another quotation mark on line 9. In this case, right now I'm at line 16, so I'm just going to go 9 and then a capital G, move to line 9, get into insert mode, then we roll from there. Okay, we'll try compiling again. Now we're missing another one. That's on line 11. This is it's one of the joys of programming. Sometimes you miss things, and that's okay. It's easy enough to fix. Compile, everything works. Java-C Boolean flags. Oops, Java Boolean flags. There we go. If we give it a number, if we give it a valid number, something like 21, then it says good job. If you give it an invalid number, let's say something like 862, it'll say error, the number is not even, error, the number is not a multiple of 3, error, the number is greater than 30, sorry, there are 1 or more errors. Okay, so we've got a pretty verbose output. Whereas if we did this with one of our other programs, we might not necessarily get the same verbosity with our output. Let's try a different number. Let's say 6, right? So it's going to be even, which is a problem, but it's also less than 10. Also a problem. Whereas, and then if we compare that with with our nested if demo, and we try 6, the only error that we're going to get is that it's not an odd number, that it's even. Okay, so we get less information using the nested if method. In terms of wrap-up, next time we're going to talk about logical operators, which let us more compactly evaluate more than one thing at once. We'll also talk about the ternary operator, which is a faster way of writing in the if statement, though it's also a little bit more complex, and the switch statement, which is a really good use for certain types of if-else blocks. In the meantime, take a look at the practice exercises at the back of Chapter 3, but ignore the ones that talk about loops, as we're not going to worry about those until after the first quiz. All right, thank you, and we'll talk to you in the future.